In today's lecture, we will be discussing about the methods to be followed when we want to appear for a practical exam. In this video, we will be discussing about the approach of a student towards carrying out an experiment. Now, this video emphasizes on the approach of student. Now, first of all, if we are supposed to face a practical exam, we need to first know the importance of practicals, the importance of the experiment. Now, we being pharmacists, it is a must to have a thorough practical knowledge in addition with a thorough theoretical knowledge. The theory and the practical should go hand in hand. Now, when you're having any practical exam, most of the students will be facing many problems. Now, how to start with the preparation? What are the concepts we need to consider while preparing for a practical exam? So, all this will be discussed in this video. Now, before you start with your preparation, list out all the experiments, what you have done till now. Now, check the relevance of the practicals with the theory that have been covered so far. Now, list out the experiments. Now, list out the various chapters in your theory and match the experiments that are related to a particular theoretical class or lectures. You'll get to know, okay, from this topic, we have performed this experiment. So, you'll get to know the kind of experiments that you have done in relevance with your theoretical class. Now, first you need to check your theory class and your practical session. Now, if you do this kind of analysis, it'll be really easy for a student to remember the practical, the procedure involved in the practical, the theory involved in the practical, and also the class lectures. So, if we study by keeping the theoretical like the theory class notes along with the practical notes, it will be very much easy for a student to know the concept. It's not just remembering the concept, you need to know the concept. Then it'll be very easy for a person to calculate the observations that have been noted down during the experiment. So, the first step is we need to know the importance of the practical that we are carrying out and how far that is relevant to the theory class. Now, first, we'll get to know the experiment title. So, what experiment we are performing. So, suppose, for example, if we are doing the determination of viscosity. So, the determination of viscosity. So, our aim should be to determine the viscosity of the given sample. So it is the viscosity parameter. So obviously the given sample would be a liquid. So our aim for that experiment would be the determination of a viscosity for the given sample, for the given liquid sample. And for example, if you are asked to compare the viscosities of two samples, then it would turn out to be a comparative study. Your aim and objective would be the determination of viscosity of the given samples. Now, we being a pharmacist, we need to know how far this experiment is important. Is it really important for a pharmacist? How far it is important and why it is important? You just make a note of it. Like write the title name. First, write the experiment name. And from the experiment name, we'll get to know the aim and objective. Then, from the aim and objective itself, we should be able to draw how far this experiment is useful for a pharmacist. Means the application of the experiment and how far it is useful. In which kind of dosage forms it is useful, in which kind of formulation type is it useful. So as the name itself indicates, the viscosity, of course, it will be useful in the liquid dosage formulations. So this is how we need to know the applications of the experiment. Now, our experiment deals with the determination of viscosity. So what could be the applications of this particular experiment? If we get to know the viscosity, how far that information is useful to formulate or to improve the stability of a formulation. How? That we need to think. Suppose if the viscosity of the given sample is much higher than, we'll be having some standard values. If it is much higher than that, means the final formulation would turn out to be very viscous. If it is less viscous, the final formulation would turn out to be very less viscous. And for formulations like emulsions, it need to have specific certain viscosity. So it is always important to determine a viscosity to know the nature of the formulation and to know how can we improve the stability of a formulation. Suppose few formulations will be stable enough in high viscous nature, and few formulations will be stable enough when we add viscolyzers, means viscosity enhancing agents, like in few suspensions to promote a controlled flocculation. We need to add viscosity enhancers, means viscosity improvers. That is how this kind of experiment is really helpful to improve the stability of a formulation. So we need to explain like this. So for example, if you are given to write the application of one experiment, you need to think how this experiment can be extended to the different areas of your subject. And what is the aim of this experiment? And what is this experiment about? Why is this experiment to be practiced? Why? To know, of course, to know the parameters. So be it viscosity, be it surface tension, be it like critical micellar concentration, and how this experiment can be performed. How? Now that we'll be discussing in the procedure. And the most important point is the applications. And we have discussed how this experiment can be applied in different areas and how this experiment would be helpful for a pharmacist. So this should be your approach towards each experiment when you are going through the procedure, when you are going through the theory or the principle involved in each experiment. Do always remember, if at all, if you are appearing for any practical examination, it is not just the procedure that is important, it is the principle or the theory involved in each experiment is the most important point. Next is the principle involved or the theory involved. What is the actual theory involved in that particular experiment? And if at all, if that experiment involves any formula, that has to be discussed in this part. For example, let's see this. And we are discussing about the determination of viscosity. We have taken this experiment as an example. And let's see the principle or the theory involved in this. So first of all, you need to write down the definition of that particular parameter. If you are asked to do an experiment related to viscosity, then you would start with the viscosity definition. And if you are asked to determine surface tension, you would start with the definition of the surface tension. So be comfortable when you are writing a theory involved in particular type of experiment. If you are not able to write down the theory, first start with the definition. And you need to write down the units in which the particular parameter is to be expressed in. Because this is the practical, we will be determining viscosity, so we need to report the results along with its units. So we need to mention the units of the particular parameter, and we need to discuss the actual principle or the theory that happens during the experiment. For example, in this experiment, we will be using Oswald viscometer. Oswald viscometer. So during this usage, now you can relate this video with that of your rheology theory class. It will be very much useful for checking the relevance. Now from this principle, we would be able to see what actually happens during the travel of the liquid. Now we are checking the viscosity of the sample given. So we need to mention the formula that are related to this experiment especially. And we need to note down the expressions or the equations. We need to write down what each factor denotes. Rho is the density, rho 1. Take if say 1 is of unknown sample and 2 is the known sample. Now here in this experiment, we always consider water as the known sample because we already know the density of the water. So it'll be very much easier for us to determine the viscosity of an unknown liquid. So from this, we'll get to know. So the theory or the principle involved, whenever if you are asked to write about the theory of any experiment, you need to first write down the definition, and next write down the units that are involved, and then make sure you should write the mathematical equation or the expression involved in that parameter, involved in that experiment procedure. It is very important, and it also make sure you need to write down what each parameter stands for. So this would be your the theory and the principle involved. And the next one is the procedure. What we need to include in the procedure? The main thing, whenever you come across any experiment, you should be able to know what are the equipments that we are going to use and what are the instruments that we are going to use and what are the glassware that we are going to use. There would be special glassware for few experiments that we need to know. For example, in the determination of surface tension, we would use a stalagmometer. It is a specialized glassware stalagmometer which looks like a puppet but with a bulb at the center of the tube. And in case of the viscosity determination, we will be making use of Oswald viscometer. This is the Oswald viscometer. So whenever we are studying a practical or the procedure involved in any experiment or any detail of experiment, make sure we should study this practical along with the theoretical lecture notes. It will be much easier. We already discussed about this topic in the theory class, and we can have like a relevant explanation like side by side. This practical might go in parallel with the theory class. Now, to start with the procedure, first of all, we need to know what are the special glassware that are used and what are the special equipments or the instruments that could be used for this experiment. Now, for this experiment, it is quite obvious we'll be making use of Oswald viscometer. Make sure what are the equipments that are used. So, the questions regarding practicals might also include about the kind of instruments or the type of instruments to be used in that particular experiment. For example, with respect to this experiment, I might ask about write down the viscometer, various viscometers that are used to determine viscosity. We are having a list of viscometers apart from your Oswald viscometer. Right? Oswald viscometer comes under the category of capillary viscometer. Similarly, we'll be having many other viscometers like cone and plate, cup and bob viscometers like that. And make sure to know what are the various steps involved. First of all, while writing a procedure, we need to make sure that we need to write the special equipments involved or used or any special glassware or the instruments to be used, and then the steps that are involved. The most important point in the practical session is making a note of observations. For example, if we are discussing, here we are discussing the determination of viscosity, our observations include a tabular column. Make sure what are the parameters that are to be noted. As we discussed in the theory involved, we need to know about the formula, the relevant formula to be used with the experiment. So for this experiment, we being a pharmacist, we should have a good knowledge on the mathematical formulae or the mathematical expressions. Now if we get to know this formula, it'll be very easy for us to draw an observations table. It will be very easy because from this formula we will be knowing what are the parameters that are to be determined. Suppose this is the viscosity of the liquid to be determined. Of course, this is the viscosity of the standard liquid like water, and rho 1, rho 2 is the density, and T1, T2 is the important parameters that are to be noted. Time taken by the unknown liquid to fall from the upper mark till the lower mark, and T2 would be the time taken by the water to move from the upper mark till the lower mark. So it is quite easy for us to draw observation table. It is not always necessary to remember the table. It is always necessary to remember the formula. So if we know the formula and procedure, we can make our own observation table, like the name of the sample, like be it water or any sample number 1. Next is the density. Next would be the column, density column. So what is the density of water? Write down the density of the liquid. We can make a note of the density of the liquid or the sample that is given. And do always remember, whenever we are carrying out any experiment, we should do in 2 trials, and we'll be having 2 values for each sample, so we can take an average of these 2 trials. The purpose of carrying out the experiment in 2 trials is just to avoid errors. The time is taken. The average time of flow is noted. Similarly, 2 trials are carried out for the sample and take down the average time of flow. The viscosity of water is constant, like the value would be known, and by cross multiplication we'll get to know the viscosity of the given sample. That after doing these calculations, we'll be noting down that value here. And by the end of the experiment, we are having some observation table showing the time of flows for different samples and the viscosity of the different sample. That's how we can know note down the observations. So the observations for few experiments would just include tabular columns. For few experiments will include microscopic observations, like the determination of particle size. Such kind of experiments would include microscopic observations, because for few experiments we'll be making use of microscope, micrometer, to determine particle size, to determine the globule size of an emulsion, and to determine uh, the stability of a microemulsion. We'll be making use of a microscope. So the observations would include not just the tabular columns, would also include the microscopic observations. And from these observations, with the help of the formula, we'll be calculating just like this. With the tabular column, the help of tabular column, and with the help of this formula, we can calculate the results. So observational data incorporated in the formula, and then interpretation of the data. We'll get to know, okay, the value of viscosity of the given sample is. That data will be writing down in the report. Suppose if we are not able to write down the report, there is another method, easy way for us to report the data. Is, suppose our aim is to determine the viscosity of the given sample, then our report becomes our aim itself turns out to be the report. The viscosity of the given sample was found to be our value, what we get here, value, along with the units. This is how we can interpret the results by doing the experiment. And there are few experiments which need a graphical representation. So in that case, we being a pharmacist, we should clearly know what are the parameters that are to be taken on the x-axis, that are to be taken on the y-axis. We being a professional candidates, we should always make sure to represent specific axis. For example, is it x-axis or y-axis? Do specify them. X-axis and y-axis. Do specify. Do not plot a graph like this. No, this will not be valid. You need to specify the axis along with the origin. And then make sure to write the parameters on the particular axis. What parameter we are going to take on the x-axis and what is the parameter that we are going to take on the y-axis. Suppose we get a graph like this. How can we interpret the data? So for example, if we take a time on this x-axis and the concentration on the y-axis, say for example, so as time passes by, the concentration increases and then it gets decreases. So at what time we are able to see the highest concentration? That is how we need to interpret the data from the graph. We should always make sure to combine the graphical presentation along with the observation table. So we need to make exact relevance with the observation data and the graphical data. Always make sure, if at all, if the experiment that you are asked to do requires a graphical presentation, we need to plot a graph for better understanding. For practicals, it is a must. And from the calculations or the observations, we'll get to know we need to infer or conclude the result, and then we need to report the result. So to carry out a practical, we need to follow all these steps. Then we can know that yes, the student has a good thorough knowledge on the practicals. So for a practical to be done, all these steps are to be included. You need to know the purpose of the experiment, what is the aim of the study, and what is the principle, the important equipments, and the formula used for this experiment. Procedure, if we get to know the principle involved, it is very easy to know the procedure. It is not always to it is not always a must to remember the procedure. If we get to know the principle involved, we can easily do the experiment. If we get to know how to handle an equipment, it is always easy for a pharmacist or for any person to carry out the procedure. The most important point is we need to remember the formula, and from the formula it is not always necessary to remember the observation table, because if we get to know the formula we can make our own observation table. Calculations would be much easier if we remember the formula. And the most important point is reporting the result. So these are the things we need to keep in mind while studying or while going through the practicals. It is always recommended to go through the practicals and the theory side by side to get the better understanding. If we get to do this parallel study of the practicals and the theory, we'll get to remember the things a little longer. Hope we'll practice this kind of study. And if you have any doubts, do let me know, and you can ask me through my mail. Thank you.